Perfect. Thank you so much. Wow, I haven't done anything yet. Wait to clap until I actually do something. No, thank you all very much. We're going to try to make this really fun. I'm honestly thrilled and very humbled to be here today. This is my first ever KubeCon. I've been a YouTube attendee for the last few years. It's been an incredible week. So hopefully I'll be able to share some stuff here that you'll be able to take away. But also, one of the things that I really love about KubeCon and this community is that I also want to open this up to a dialogue. And whether it happens in this room or after the fact at the booth on Twitter and community stand-ups, is we're kind of moving this world of serverless and Kubernetes forward. So as just mentioned, I'm Jeff Hollan. We'll have a fun session today. In fact, I switched to this first slide. I was going to make this entirely Star Wars themed and have like GIFs all over the place from Star Wars stuff. And I had all the jokes written. But then earlier this week, as I was going through the deck, I was like, I don't know if someone from Disney is going to be here or they're going to catch wind. And I do not want to get sued by Disney. So just use your imagination. And I still snuck some in at the end. I've got a fun demo that will tie it back to Star Wars, which I'm very in the mood for right now. OK, so to start with, serverless means a lot of things, and it means nothing because marketing. But for now, just focusing on how I think about serverless to set the context. Regardless of technology, in my mind, serverless is really about enabling developers, IT admins, really anyone dealing with code to be able to focus primarily on just their application logic. And all the other pieces that you're usually thinking about when shipping an application, you don't have to worry about anymore. They're taken care of by the platform, by tools behind the scenes to enable you to be faster and more efficient. Now, serverless has a lot of attributes. This isn't a requirements list. There's a whole spectrum. Some things are serverless and they have some of these, but a few of the qualities are things like event-driven. Something triggers an event. It triggers your code to say, hey, something's happened here to run. And as part of that event-driven, it means that that compute will be made available on demand as well. So, hey, an event happened that I need to run this code for. Let's make sure that we have compute available just in time for that event. And there's often this aspect of pay per use. And again, this can vary. There's an entire spectrum. Sometimes pay per use is like running in AWS Lambda or the Azure Function Service, and you literally only pay when your code is actually executing. But pay per use might also just mean that because you're doing event-driven and on-demand computing, that you're scaling your resources only when you need them. And so you're able to more efficiently use your underlying compute. So with this in mind, Azure Functions has been around for a while. I've been on the Azure Functions team and working in serverless at Azure for about 5 years now. We see it used all over the place for a bunch of different things. In fact, I was just looking over the last 3 weeks, there's been over 250 billion executions that happened around Azure Functions. So we have a bunch of stuff that make up those executions. Often where people get started are simple automation type tasks. Hey, a pull request gets open. Can you add this label? Can you add these checks? Hey, at 5 o'clock p.m., can you shut down these machines or run an update? Can you post to Slack when it's lunchtime and ask for a vote on where we want to go for lunch? Really good way to get started. I often call automation and serverless like the gateway drug. But often it grows from there, and people can start to use them for other things. Glue is another very common place to see serverless containers and functions used. I've got Mongo over here. I've got SQL over there. They need to be able to talk better to each other. Maybe I can glue them together with some serverless. Rapid APIs. I think about how Netflix has documented how they're using serverless tech and serverless methodologies, where they have front-end developers writing the UI for Netflix who need to be able to fetch data from back-end services. And rather than having to spin up a full microservice to fetch that data from, they empower their developers to just write little functions that go grab the data that they need and return it back to the UI. So these very rapid APIs for mobile apps, web apps, you name it, are a big one. And then as things kind of grow up, kind of the bigger ones that we see are really around event streaming and queue processing. Billions of messages funneling through queues and streams and Kafka, processing, enriching, transforming the data, making insights and analysis, full suites that are made up of hundreds of functions with data being passed around, all with those serverless principles I talked about before. Actually, a good example of this is Best Buy. They gave a talk at the Spring One conference that honestly I'd recommend checking out if you're interested, about how they're using serverless and other tools to build a modern retail experience. So they have a few cool stuff here. One is that they do a lot of processing on premises at regional data centers. They're using things like Kubernetes. You can see OpenShift here. And at some point, some of that data is going to make its way to a cloud. They're using a Kafka-like service in Azure called Event Hubs. They're processing those Kafka events. Those little lightning bolts that you see, those are functions. So they're using some serverless functions here to be able to scale rapidly, transform the data, put it into the right databases, and power things like the BestBuy.com experience. And Best Buy had a lot of requirements, right? One of them is, hey, we're going to have things like Black Friday. We need to make sure that our compute can scale rapidly at midnight or whenever. Black Friday is earlier every year. It's probably like 8 o'clock in the morning on Thanksgiving now. But at 8 o'clock in the morning on Thanksgiving, they need to be able to scale rapidly. They also had some other requirements. They knew Kafka. They loved Kafka. They're like, hey, if an exception happens, if something goes wrong, we want to be able to know that we have control to say, you know what, don't checkpoint the stream. We need to retry these messages. And the last one, which is an important one, we'll get to it later in the presentation, ordering was super important. It very much mattered if the item was purchased, item was canceled, shipment was created. What order those events get processed was very important to them. They were able to build this, they say, in a matter of weeks, where traditionally it would take them months. That's a quote from their presentation again at that Spring One conference, which is kind of a good example to set the stage here. Now, one of the things that we have been doing as a service, and as I mentioned as a fan, Azure Functions itself, like those lightning bolts, those have been open source since day one. You can go to github.com/Azure Functions. In our runtime, the way that we trigger and run your code has been open source. But there were other things that made people choose things like serverless in the cloud, things like that scaling that I talked about. So one of the things that we've been working with and talking to the community, some partners like Red Hat, is how can we start to bring more of these experiences to that other side, to where you don't want to have lock-in to a specific vendor like Azure, but you want to run these serverless workloads anywhere. And one of the first things that we noticed from some of our learnings is that by default, Kubernetes is not very well suited for event-driven scaling. And that's because by default, Kubernetes can really only do resource-based scaling, looking at CPU and memory. And in many ways, I think that's like treating the symptom and not the cause. Yes, a bunch of queue messages will eventually cause the CPUs to rise. But the real thing I want to be able to scale on is, oh, there's a million queue messages here that need to get processed. And that's just not what Kubernetes is doing by default. So we looked at this, we looked at some of the learnings that we had, and the thing that we kind of developed and released, again, in partnership with Red Hat, was KEDA. So this just went 1.0 this week on Tuesday. And KEDA is that event-driven scale controlling that can run inside of any Kubernetes cluster. So KEDA can monitor the rate of events to proactively scale a container even before the CPU has been impacted. So in the example of queues that I was using, KEDA can actually say, oh, wow, there's a million queue messages here. I need to hurry and scale out to a bunch of replicas. I can't just wait for the autoscaler defaults to scale it out. All it's doing behind the scenes is just feeding this data into the native Kubernetes APIs. We didn't reinvent anything here. It allows containers to scale to and from zero as well, in the same way that a function or a Lambda in the cloud can scale to and from zero. It's completely open source. We just worked with the serverless working group and got buy-off. We're now working with the oversight committee, and our plan is to onboard this to the CNCF in the coming months. Sorry, I was eating some popcorn before. I think I had a kernel stuck in my throat. Anyway, so onboarding to the CNCF, which we're excited about, and install into any cluster. So KEDA is very non-intrusive. You can pop it into a cluster where you already have deployments, and you can just map it to only scale the things you want to. It's not a decision that's going to change everything. And it's got a bunch of extensible trigger sources. It knows about Azure events. It knows about Kafka, RabbitMQ, NATS, Redis, AWS, GCP, a lot of contributions from the community as well to improve this library. So to kind of show you this in action, I'm just going to do a very quick demo. I have a cluster already set up. And the only thing I have in this cluster right now is, well, first I've already installed the KEDA operator, which I'll go into how that works in a second. And then I have this RabbitMQ consumer, this container that's going to trigger and consume RabbitMQ events. And you'll notice right now it's scaled all the way to 0. And the reason it's scaled all the way to 0 is because KEDA knows that there's nothing on that queue that it needs to run. Let me actually switch to the right directory. So what I'm going to do here is I'm going to run this job that will publish 1,000 messages to this queue. Let's go ahead and watch what happens. You'll see the job spinning up. The job just completed, so it's publishing those messages. And right away, you'll see that a consumer has just popped up. KEDA noticed, oh, there's actually work to be done here, and it's now added one. But even before I finish the sentence, it's not just waiting for the CPU. KEDA actually can see, oh, there's actually 1,000 messages here. We want to be able to very rapidly scale out. So I'm already at 4. I would guess by the time that I get to the end of this next sentence, it will scale out to 8. There we go, like magic. It's going to continue to scale out, this bursty serverless scale, consume those messages. And if we left this open for about 30 seconds, once that queue is empty, KEDA will help drive the scaling decisions to bring that all the way back down to 0. So I'm providing these serverless containers to consume compute only when I need them, because KEDA is helping Kubernetes know I only need these containers to run when there's actually events to process. So very simple demo there to see kind of that in action so you're not just looking at slides. So what's happening behind the scenes here? As I mentioned, there's an operator. This you can install with like a Helm chart, YAML, whatever else. Super lightweight, entirely written in Go, that's helping monitor those event sources at a configurable period. And it also has with it those scalers, the knowledge of those event sources. This is extensible as well. You could write a gRPC discoverable scaler, or you can contribute directly to KEDA. And the other pieces here is the metrics API that Kubernetes exposes already, and the horizontal pod autoscaler that knows how to talk to that metrics API. And the other piece I have here is my event source. In the demo I just did, it was RabbitMQ. This could be Kafka. It could be AWS SQS, right? Could be anything. And now the last thing I have is I've got my deployment. I have my actual deployment, my set of containers that I need to run in Kubernetes. And the way that I describe my relationship between the deployment and the event source is with this custom resource called the scaled object. So I don't know how much you can read this now. I know the font's a little bit grayed out. All this really has is it says, hey, what's the deployment that I'm scaling? That scaled target reference, which I'm calling my deployment here. I can set some metadata, like how frequently to pull for events. You can control minimums and maximums if you want to make sure. Maybe you never want to scale to 0. Maybe you never want to scale above 60. And then you can just define the metadata for your event source. Like in this case, hey, I want to listen to Kafka. This is where to find Kafka. This is the consumer group I care about. And this lag threshold thing, that lets you control how aggressively it scales. Sometimes a single message might represent a lot of work, so you want to scale out very aggressively. And other times, 1,000 messages might just be a second of work, so you want it to scale more conservatively. You have some options here to control that more as you need. So once I'm ready to go, I can then just apply that deployment to Kubernetes, throw it in there. In this case, like I did before, I've graded out. It's scaled to 0. And all the KEDA operator is doing now is it identified that scaled object, and it just constantly is asking that event source, how many events are being generated, right? Is there work to be done here? And eventually a queue message or a Kafka stream message or whatever else is going to land on that event source. KEDA is going to identify it, and just like you saw in my demo, it's going to scale it up to 1 and then potentially help the HPA. And again, the HPA is doing all the scaling here. KEDA is just feeding it the right data. Eventually scale it out to as many as you need, okay? So that's kind of how KEDA works in a nutshell. And there were a few core principles that we as a community had as we were building KEDA. The first one is we didn't want to rebuild that Kubernetes already offered out of the box. Kubernetes has an autoscaler, great, let's use that one. Kubernetes has a metrics concept, let's use that concept. It's just augmenting what was out of the box with additional data and insights and capabilities to bring up these serverless workloads. KEDA is also extremely single purpose. It's not a serverless platform. This is not trying to do everything. It only does one thing, event-driven scaling, and it tries to do that one thing very well. Super simple, very non-intrusive, 2 CRDs, and that's it. Just that single operator running in a cluster. It can work with any container and any workload. I'll show you later today, you could take that container. It could be running your own custom code. It could be running an Azure function, doesn't matter. Any workload, if it has an event source, KEDA knows how to scale it. We also, in kind of a design principle and what makes KEDA different, and we'll get to this a little bit too, we wanted to make sure that application developers could take advantage of all of the features that make message brokers great. RabbitMQ, Kafka, NATS, all of these have really rich pieces of functionality that can improve my application. We didn't want that to get lost in the translation of bringing serverless containers. And then finally, it's open, built with the community, which we'll go into more too. So there's one scenario I want to call out quickly that's important to note when you think about these rapid scale out and also rapid scale in. And that's, what do I do if I have a long-running execution. This came up very early with KEDA. It came up with a few of our customers that we were working with, where they were like, hey, yeah, Jeff, in your demo, you dropped 1,000 RabbitMQ messages, and you pretty much just printed out hello world. But what if every queue message actually represented a significant amount of work? What if every queue message is a video that has to be transcoded that's going to take 8 hours? And the problem here can be, imagine I drop 1,000 videos that need to be transcoded. KEDA sees it, you've configured your scale settings enough, and KEDA scales you out to a number of different replicas. And I've illustrated here, there could be like a progress bar. This is how far they are on their 8-hour job, okay? You can see instance 2 and 3 are close to being done. 1 and 4 have just got started. Well, the challenge is KEDA's feeding these metrics into the HPA, and at some point the HPA might say, hey, you know what? The queue's actually slowing down a lot. We maybe don't need 4 instances anymore. Let's go ahead and start to scale down. And the way HPA works, the way I like to think about it, is that the HPA is very much like Thanos, and that it's going to snap its fingers, and it's going to get rid of a bunch of my instances, but it has no regard if you're Spider-Man or Iron Man. It's just going to snap its fingers. So the problem here with KEDA is that if I'm 7 hours into an 8-hour job, and the HPA snaps its fingers, it's very possible that the thing that only needed 10 more minutes just got killed. And so we were trying to figure out, how do we solve for these more kind of advanced messaging workloads that might be long running? So there's 2 options that we have to combat Thanos. We call them Hulk and Iron Man. This presentation's full of spoilers, by the way. So if the words Baby Yoda, or if you're sensitive to those words, you might just want to leave now. Okay. So there's 2 options you have here. Option 1, you can just leverage the out-of-the-box Kubernetes lifecycle. So Kubernetes does a few things. It can do like pre-hooks. It sends a SIG term. You can leverage those to delay termination. If you're 1 hour into an 8-hour job, Kubernetes can say, hey, I want to scale you down. And you can be, just hold on a minute. And you can tell it to just hold on a minute for hours and hours and hours. It works. Some people don't like it a whole bunch because you see it as a terminating state for 8 hours, but it's an option. The other option that's really cool here is that while we've been talking a lot about scaling deployments, with KEDA, you can also tell it, you know what, I have an event source here, but for every event, I actually want you to create a job. And in that case, KEDA will schedule a job for every event. You can control the parallelism, and those jobs can run to completion. So in the video example, I might have 1,000 things drop in that queue. KEDA will spin up a few jobs, wait for a job to complete, clean it up, spin up another one. And that way, I don't have to worry about running to completion. So the pattern's a little bit different. The intent of those jobs would be grab one event, process it to completion, and then terminate. But it works. It's a really useful pattern that I wanted to make sure I called out here to enable those long-running scenarios. All right, let's see what I have next. Oh, this is a great discussion point before we get to the last demo. Is this the best way to do event-driven? Okay, and I specifically use the word the best. Because that's a very loaded question. There's very rarely ever the best way to do anything. But I did want to present some of the reasons that we feel the pattern of how KEDA is doing event-driven containers is useful and a useful tool to have in your toolbox. And there's a few patterns that are pretty common here, especially in the world of serverless. And we're not the only ones who do it this way. And there's not just one project or one company who does things the alternative approach. But these are kind of the 2 most common ways to handle event-driven. So how KEDA's doing it, and some others like Nucleo, is that you have your event source, and the thing that's actually consuming those events, the thing the developer is writing, they're in charge of actually connecting and pulling that event directly from RabbitMQ or Kafka. The other alternative that's super common for a bunch of serverless platforms and frameworks is that you have your event source, but all the developer writes is an HTTP container. The whole world is HTTP. All I have to think about is I'm going to write an event-driven container, expose an HTTP endpoint, and then there's some channel or adapter or something else that actually is converting those messages. You can imagine it's Kafka. Something's pulling those messages off Kafka and then throwing out HTTP requests to any serverless containers that are interested. So there's pros and cons to both of these approaches, but I want to help explain where KEDA kind of fits in here. So let's look at the one I talked about, the alternative approach. The big pro here is that if I'm a serverless developer, if I'm a developer who wants to do an event-driven container, I don't have to know anything about how to use the SDKs. SDKs can be a pain in the butt to use. I don't have to think about that in this model. I just think about exposing an HTTP endpoint, which every language has a great example of how to do. Everything becomes HTTP. Everything becomes gRPC. So that's great. But there are some cons here as well. It becomes much harder for a developer to leverage some of the native event capabilities. Think of a queue message. I don't know how many of you have used a lot of queue technologies before, but when you're consuming messages from a queue, there's often this very common gesture where you lock the queue message to say I'm working on it. And as a developer in your code, you actually have a few choices you can make. You can say I've completed processing, which dequeues the message and it will never get processed again. You can abandon that message. You can say, hey, something's gone wrong. I wasn't able to finish doing this. Someone else should go try to do this one again and abandon it. And then the third choice is you can dead letter it. You could be like, you know what, this message is crap. No one should waste their time on this message again. I'm going to explicitly dead letter it. So even just with queues, there's these three distinct options. If I'm in this world where my code has been separated from the event source by this middle layer, it becomes much harder for me to know how do I do an HTTP response that may be an abandon, may be a complete, and it may be a dead letter. It's a lot harder for me to reason around it. I have to re-engineer those patterns for every single event source. Some context will also always be lost in transition. As you're converting something from a rich type and then transferring it to a bunch of headers and a body, there's always going to be some stuff that's going to have to get lost in the mix, especially when you want to make it language agnostic. So it's a trade-off you have to be aware of. It also becomes really difficult to do some of those common patterns like ordering. I mentioned in the example before, Best Buy really wanted serverless, but they really needed ordering. We work with a bunch of financial customers who very much care when Jeff bought Microsoft stock, when Microsoft stock went down, and when Jeff sold that stock. The order of those three events are extremely, extremely important. Okay? So I need ordering, but if I have this middle layer, it's hard for me when I'm shooting off all these HTTP events to make sure that HTTP request 1 got processed and completed before HTTP event 2. There's ways around it. You could be like, actually only send one request at a time and wait for it to finish and then send the next one. But again, things like Kafka just have this out of the box. It's like grab a whole batch of messages, process them in order, super high throughput, super high control. The only other one I'll flag, this is more of a nit too, somebody has to worry about the SDKs. Someone has to make sure that the events are successfully getting pulled from something like Kafka. In this model, if it's not the developer, then it's someone else who has to make sure that all these event adapters are working, they're connected to the right sources, and that they're everything making work. And in my mind, very often as a developer, I'm okay being aware of the fact I'm pulling from Kafka, and I'll be the one who worries about that SDK. Okay? So again, this isn't necessarily wrong. It's not necessarily right, but there's important trade-offs here, and that's why with KEDA, we just wanted to call out, this is a different approach, right? KEDA will monitor the rate of events, and it's going to scale your container, but it assumes that your container is going to connect whatever protocol it wants to. This could be HTTP, it could be AMQP, it could be MQTT, I don't know, there's 1,800 different ways to pull messages from something. But here we can support them all without having to build adapters that can do the translation layer. Okay? So it's something I wanted to kind of posit into this room. Now, the downside to this approach, though, is that SDKs suck. Okay? I don't care what SDK you're using, they all suck. So for example, I love RabbitMQ. I really do. This is an example of the Hello World RabbitMQ Python example. And so as I kind of just scroll through this code, all this is really doing is it's pulling a message from RabbitMQ and printing hello world. But I need all this code to just establish the connection, peek the message, all those other things. That's a whole bunch of code that if you're using the alternative approach, the developer doesn't have to write. So the only last thing I want to show, and then I'll do our last Star Wars demo, is that this is where we start to think more programming models and programming frameworks can help fill in that gap. So I mentioned at the beginning, Azure Functions is completely open source. Just ignore the word Azure for now. We'll take care of that. It's all on GitHub. It's open sourced. This is what an Azure function looks like that's doing the exact same task. I just say I have a function, I care about a queue, print hello world. Now the SDK is still there, but it's managed by the Azure Functions runtime. So as a developer, I can say I want to write a serverless function, just write my 4 lines of code, still use KEDA. It's still doing peak locking behind the scenes, and I can even pass in SDKs to say complete, abandon, checkpoint, whatever. But I'm not having to worry about it in my face as much. Okay? So is this where? Nope, not quite where I do it. So you might be looking at this and thinking, Jeff, why are you talking about Azure again? We were talking about KEDA and Kubernetes. You can take any Azure function. You can run init Docker only and Kubernetes Deploy, And you can deploy any Azure function that you write wherever you want to. You could deploy it to Azure. You could deploy it to Google. You could deploy it and run it on premises. You don't pay us anything. There's no license. We don't care. You can take that Azure function and run it wherever you want to. So with that, here is our final demo. This is a fun one. So what I have here and what I want to build, I have here a dashboard in Power BI. And you might be thinking, Jeff, this is KubeCon. Why is it in this Grafana? And to that, I would say, I don't know how to use Grafana. But that's OK. You could do this in Grafana. I'm very confident. So this dashboard is very empty and lonely right now. And what I want to do is that, for those of you who are unaware, Twitter is a flurry right now with information about Star Wars, everything from Star Wars Land to Baby Yoda to the Rise of Skywalker. Ben Solo was trending yesterday, but I was too afraid to dig into why. So I want to be able to write a serverless app that can scale to the volume of all these tweets happening about Star Wars and populate this dashboard with some insight about it. And so to do that, I'm going to use my favorite tool, of Visual Studio Code. And I have a Kafka stream that I've been publishing every tweet in real time to Kafka. Now, I have here an Azure function. So you'll notice there's no code here about Kafka. I've just said, hey, I want a Kafka trigger. You worry about pulling the messages from Kafka. I'm going to pull in these events in order, process them in order. This is in TypeScript. Could have done this in Python, whatever, Java. And here I'm just going to pull in the Twitter event. I'm going to run some sentiment analysis on it. Are they happy about Star Wars? Are they angry about Star Wars? I assume everyone's happy about Star Wars. Maybe should I bring up The Last Jedi, though? That's a more controversial one. And then the last thing I'm going to do, I'm just going to make a simple HTTP post to that real-time dashboard. Now, what's nice here, and one of the things that makes this programming model nice, I can go ahead and set a breakpoint, press F5 to start spinning up and actually run that open source Azure Functions runtime directly on my machine. You'll see here's the beautiful ASCII art, also represented on my shirt, saying, OK, we're going to spin up. We're going to look at this app. We're going to load up the user code that Jeff wrote. Here, it actually already pulled a tweet. So you can see here I hit my breakpoint. Let's just step through this a bit. Whatever tweet this was got a score of 0, so it's neutral. And we could even come in here and see, what is this tweet about? Hopefully there's Star Wars, The Mandalorian, Disney Plus, Baby Yoda. I warned you. It mentioned Baby Yoda, OK? So I can breakpoint debug this. And when I'm ready to go, I can publish it. But let's just not do a boring publish. Let's do an exciting publish. So I'm just going to run one more command. I'm going to switch the context of my kubectl. I'm going to connect to Google Cloud. So I'm going to switch here. Let's do this whole thing on Google. So I've just switched over to a Kubernetes cluster running on Google Cloud. And here's where I can run the func Kubernetes Deploy. It's going to look at this Azure function. It's going to put it inside of a Docker container, build that container, publish it to my registry, public or private, and then deploy that to my cluster. Now, I don't want to have to worry about Wi-Fi and publishing this image, so I actually already built the image this morning. So let's just go ahead and apply it quickly. Not that one. Kube apply f deploy.yaml. So I took that function, and I just deployed it. And here, we'll switch to this screen where it's a little bit bigger. I can do the same thing where I say watch pods. And you'll notice as soon as I deployed it, it's actually already said there's actually a bunch of tweets happening. So it spun up one of my Azure functions in Google Cloud Kubernetes. And I would imagine, too, and assuming you can all participate in the room as well if you tweet anything about Star Wars, there's enough tweets happening right now. It's automatically scaled me out to 4 of those functions. So now the real moment of truth. When we switch back to this dashboard, this has now come to life with real-time data, the real-time sentiment. You can see that heartbeat of everyone in the world who's tweeting about Star Wars right now. I see some tweets coming from over here in San Diego, so way to go, room. Way to participate, right? So we can see here, there's a bunch of weird hashtags. I don't see anything, hopefully nothing inappropriate. This is unfiltered. But that just gives you the idea. Is there something bad here? I hope not. Yesterday when I was testing it, there was something suggestive in one of the tweets, and I was like, please do not retweet this in the middle of my presentation. People just need to figure their lives out. But again, this is a really cool way that in the 40 lines of Azure Functions runtime code, by deploying this to Kubernetes, in this case Google, turning on KEDA with that serverless scale, I've been able to write a serverless app that can scale to millions of events but run it wherever I want. No vendor lock-in, event-driven scale, event-driven containers, whatever I need, okay? So that's a fun way to see what you can start to do with this stuff. So that's it. That's all I had to share today. We'll have a little bit of time for questions, if there's any. A few resources, if you're interested. KEDA.sh, that's the landing page. It will give you the docs, the deployment scripts, everything you need. The code is all on GitHub. And we also have community stand-ups every Thursday. So if you're interested in participating, you want to help with the design, you have feature requests, you want to contribute some scalars, docs, samples, whatever, we love it all. Please, I would encourage you to join those stand-ups. Thank you all very much again. You've been so welcoming. I mentioned this was my first KubeCon. I really hope I get to go to more of these. This has been such a fun conference. My Twitter handle is there at the very bottom, @JeffHollan as well, if you have any questions as well. So with that, we do have like 3 minutes. If there's any questions in the room, we can answer them here. But thank you all very much. It's been a pleasure.
Thanks, Jeff. OK, I will run around with questions. But just before that, please do remember to rate the session on sked.com.
Please do.
I don't know who was first, but I'll go for whoever's closest.
Thank you. Yeah. Excellent presentation. So I'm fairly new to Kubernetes, OpenShift, and those sets of technologies. I've heard of Knative, serverless technology, but don't know the details of it. But I was wondering if you could compare and contrast Knative to KEDA and where there's any intersection or how they integrate with one another or overlap, things like that.
Yeah, great question.
Okay, thank you.
I think from the biggest one, Knative is an entire, I kind of mentioned KEDA's super single purpose. It only does the event-driven scale thing. Knative is like a full platform. It's got Knative serving, Knative eventing. Event-driven scale is one of the 10 things that Knative can do. So that's one of the big differences and considerations. It's still evolving. We're actually, even just this morning, we've been working with the Knative team to see what opportunities there might be there. So KEDA itself is very single purpose. The only other difference is Knative eventing today does use that kind of alternate eventing strategy that I talked about, where KEDA's different. So there's kind of a change there, but you can also mix and match these two. Like we've been working, I mentioned, with Red Hat. Red Hat's obviously involved with Knative. They're using Knative with KEDA. And they even have customers who are using that with Azure Functions. So there is a bit of mixing and matching. KEDA, though, very single purpose. Knative is a much broader kind of platform thing. I think that's how I'd answer it. I'm looking at the Knative row to see. I'm not seeing any disapproving shakes, so we'll go with that. OK.
Thank you for the presentation. Is there also autoscaling for the nodes?
Great question. So this comes up very often. KEDA itself won't do the cluster autoscaling. But because it's going to be requesting pods, it will drive that. So how it will work, you would set up like a cluster autoscale rule and say, if I need more resources, I want you to scale out. KEDA might say, I need 10 containers that each need 1 core. Those scheduling requests will drive the cluster autoscale decision. So indirectly, it does it, just not directly. You can also use this too kind of indirectly as well with things like the virtual kubelet or virtual nodes. So the one, I didn't do it in this demo because I was on Google Cloud, but if I did this on AKS, I might also have those scale out into serverless containers like Fargate or ACI. And you can also drive scale out into managed containers as well as a pattern. Great question.
A question about over provisioning. Do you handle it? If you do, how? Over provision of the pods, because you can provision too many of them, so maybe it's not necessary because the queue is about to be exhausted, right?
Correct, yes. So there is always the risk that it's like, hey, KEDA's making 18 scheduling requests, but maybe 2 is enough, and that's where those knobs in that scaled object of both the aggressiveness that you scale and also the maximums will really come into play. Especially something like Kafka, we actually enforce it on Kafka, but it will never scale out beyond the number of partitions that you have available so that you're not over-provisioning in that way. But KEDA will do the best that it can with the knowledge that it has, but there's also some responsibility to make sure you've got the right maximums and the right pod requests so that you're requesting just the CPU you actually need as well. We have time for one more. Do we have to stop at 11:30 sharp? OK, so last one, but we'll also be, there's the Microsoft booth upstairs. We can answer more there, too.
OK, just quick question. Can you like structure KEDA to do like workflows? Like, could you say, I want to have this execute in a particular order? You talked about ordering, so could you like save a workflow and then run it repeatedly in response to certain events?
I haven't tried it. There's nothing that would prevent it. The one thing that came to mind when you were asking that is there's some workflow tools, at least that I'm familiar with, like Brigade, that let you do like Kubernetes jobs and execute a workflow. I would imagine that there's a world that you could do the job thing and have that kick off a Brigade workflow, and it would actually just work. So I guess the short answer is I haven't personally tried it. I don't think there's anything blocking it, but that's a fantastic feature request that even I'll try to mentally remember, but that's something I'd love to see, that kind of stuff to kick off more of these stateful workflows as well. Yeah. Okay, so that's it. Thank you all again for coming. If you have other questions about KEDA, you can find us at the booth later today.
Thanks, everyone.